What might the rest of the century be like for our planet? As the Earth warms, the impacts of climate change become greater. Currently, the global average temperature is around 1.2 degrees Celsius higher than it was before the Industrial Revolution, and already we're beginning to see some of the effects. In 2015, most countries in the world signed the Paris Agreement, with the aim to keep the temperature below 2 degrees Celsius of warming and focus on limiting it to 1.5 degrees Celsius. Even if the temperature stays below this level, it won't solve all the issues. The 1.5 degree target has just been chosen to protect us, not as a guarantee. So, would keeping this agreement have any benefits? Alternatively, what might the consequences be if we don't? The projection section allows us to explore the possibilities, using information taken from the best climate models we have today. The results all depend on how much greenhouse gas we release into the atmosphere. So in this section, we can choose from a range of different emission scenarios to find out what would happen. For each potential future, we can observe the change in temperature over time and the impact it would have on a variety of different factors. In many ways, it's just like the observation section, with the global trend graphs and selectable regional temperature pins. This time, however, the graphs are more suited to showing general long-term trends rather than specific years. The model simulations give us access to far more data than was observable in reality, particularly before satellites became available. So, this section contains additional information that helps us to see more of the impact both on us and the natural world. We can pull up maps showing detailed climate information and how each part of the world would be affected. These are plotted for each level of global warming, the 1.5 and 2 degrees Celsius targets, plus the nightmare scenario of reaching 4 degrees Celsius. We can look at two different types of data simultaneously to make side-by-side comparisons. We can see that some areas would become wetter, while others would face severe drought. For each emission scenario, we can also monitor a range of specific risks for the planet's climate and how quickly they would increase as we move through time. We can see that even now, warm water corals are under threat. But thankfully, at least the risk of climate tipping points, the points of no return for the planet, only increase at much higher warming levels. The calculations assume that society hasn't taken any actions to adapt to the changing climate, making the consequences as severe as possible. This is accurate for less developed parts of the world and elsewhere if change happens quickly. By reducing our greenhouse gas emissions, we can both slow down the warming of our planet and reduce the very worst long-term impacts, providing us and the natural world with more time to adapt.